So the problem says find the point on the parabola y squared equals 2x. What kind of parabola is it if it's y squared equals 2x?
It's one of the things that goes like that.
Yeah, it's a sideways parabola. Yeah. That is closest to 1, 4. So just to make it so that we can graph this, let's go ahead and solve for y.
Square root 2x.
And since we were the ones doing the square root, what should be in front of it?
Plus or minus.
Okay. Anyone remember what the 2 in the front does? What transformation? It's a horizontal compression. So it's going to make it compressed this way, which means that it's going to be like this, kind of like wider than a normal parabola would be. So there's the top part of the square root. Here's the bottom part of the square root. So we have the point over 1 up 4. We'll say that that's right there somewhere, over 1 up 4. And it says find the point on the parabola that is the closest to 1, 4. So I don't know exactly where it is, but it should be like straight away from it, right? Okay, and we don't know what that point is, so I'm going to call that point x, comma, y. Are we okay with that?
I'm okay with that.
What formula do we use to find the distance between points? Distance formula, which is
x2 minus x1 over
squared
plus y2 minus y1.
Okay, so we are going to do that with these 2 points. Okay, so I'm going to go ahead and say x minus 1 squared and y minus 4 squared. Are you guys okay with that? X minus 1, y minus 4. Yes? Yes? Okay. So the distance is x minus 1 plus y minus 4. Okay. I don't want this in terms of 2 variables. That makes the problem harder to solve when I maximize or minimize or whatever. So I have a relationship up here between the 2 variables. How could I use that to get rid of one of these?
Plug that in for y.
Okay, so I don't want to do the one where I plug it in for x. No, I don't want to do the one where I plug it in for y because that's where I have to have a plus minus, and I'm going to have to do the problem twice. Yeah. So I'm going to take the x and replace it with y squared over 2. Okay. Now, when we maximize or minimize something, after we have the equation, what do we do to the equation? You take the derivative. I don't want to deal with that square root, so what I'm going to do is I'm going to go ahead and square both sides. Okay? So if I talk about a distance and I want to maximize a distance, that's going to be the exact same thing as if I maximize the distance squared or minimize the distance squared. It's going to work the same, but it's going to be easier to take the derivative of. Okay? So if I square both sides, I get d squared equals y squared over 2 minus 1 squared plus y minus 4 squared. And then now I can go ahead and take the derivative, and that's a much easier problem to deal with. So I'm going to take the derivative of the distance squared instead of the distance, but I can still use it to minimize.
And does that only work with distance?
It works with anything where you're not like doing something that would change that relationship, but I would say of the different things that you do with optimization, this is the only one you're going to do something like that on that I can think of off the top of my head. Okay, so what do I do to find the derivative of this first part?
4y over times y over 2 minus 1. So multiply by 2 and then...
Well, it wouldn't be 4.
Okay, so
2y, right?
I'm not going to do anything in my head. I'm just going to write all the work out, okay? Because some of us need that. So there's my chain rule, right? Do the derivative of the outside, keep the inside the same, times the derivative of the inside. And that's, if you think of it, that's really a 1/2 y squared. That's what that really is on the inside. So when I take the derivative of that, what do I get?
Bring the 2 down, cancel.
You get y dx.
Okay, but in this case, we don't
Oh.
need a dy dx because we already have the y isolated. We know what the y is, yeah. Okay, plus,
Just make the whole thing over 2, but that's probably
plus
Plus 2 y minus 4.
to the 1 power times 1. You don't have to write that if you don't want to.
Wait,
Add so much to the
times
problem.
times
That's so much less.
Derivative of y is 1. All right, so we have the 2y being multiplied by 1/2 y squared minus 1. I'm going to go ahead and fix that because it makes my brain happier. So when I multiply that 2y in there, what do I get?
Y cubed
minus 2.
minus 2y.
Okay, plus 2y minus 8. So I have
Minus 8.
y cubed minus 8 equals 0, right? Because it's the derivative, and you set the derivative equal to 0.
Y cubed is 8 minus 8.
So y is 2. And then even though we only have one answer, we want to check and make sure that it's a minimum. Because if it actually maximizes, that'd be weird. That'd be us answering terribly. So if I go back right here, if I plug in 0, a number to the left of 2, if I plug in 0, do I get a positive or a negative? Negative. If I plug in 100 million trillion billion, I get a very, very positive answer. Okay. So we know that it's a minimum. What do I need to do now so that I can answer the question in the context?
Find the x value.
We need to find the x value. So that's the y coordinate, right? We just found that 2 was the y coordinate. Now we need to find the x coordinate that corresponds to that.
Can't you just plug it into the original equation?
So we're going to say 2 squared equals 2x.
Oh.
Question? No question?
No.
And x equals 2.
So
All right.
2 is okay.
So we're going to say the point closest to 1, 4 on the parabola y squared equals 2x is 2, 2.
Parabola.
Yep.
Ebola, what?
Wasn't that so fun?
yes, actually.
Actually.
Oh, good.
They said
Okay,
parable.
these
They said
two-
parable
these two
and
are
not Ebola.
So, sorry.
Oh, I did not solve this on the paper. I solved it in my binder. That's fine.
So we have our notes done at this point. What is like the big takeaway from optimization? What do you basically have to do?
Like you have to
Find
find
the
the
sign
two
right.
equations.
Yeah, you have to figure out some way to have an equation, right? And then once you have the equation, what do you do? Before sign graph. Derivative, set it equals 0, sign chart.
And
Yeah.
then write
Saying
a sentence.
sign graph is-
So it's not anything new necessarily. It's just in the context of a word problem instead of the context of a formula or an equation like it has been. Okay, but it's still big picture the same thing we've been doing, right? All right, I'm gonna go ahead and hand out the assignment. I'll have the answer key in the back for you.